back to the Future Print Virtual Summit for our Industrial Print Day. I've got two gentlemen with me here today from a business called ChemStream, very innovative Inkjet ink business, Belgium-based. We've known one another for a number of years. They've quite, I think, very innovative and clever at making complex things understandable. So I think we're going to learn something today, particularly because this session is called Multi-Material Inkjet 3D Printing, a New Era in Material Science. I think one of the things that struck me with this, because I'm particularly excited by it, is that 3D printing itself has gone through a huge hype cycle, probably in the past 7 to 8 years. It seemed to dominate headlines on a virtually daily basis and then seemed to disappear. And that tends to happen with new tech, is the expectations don't quite align with the reality. However, I get the sense that that's changing, and that Inkjet is now playing a role in speciality areas. And this is where the gentlemen here today are going to speak to me about that, or to us about that. We've got Frank de Voigt, is the Managing Director of ChemStream, and Marion Steenmakers, who's the project manager at ChemStream for this particular new product. So gentlemen, I want to hand over to you about Inkjet, inks, and 3D printing. I hadn't thought that would be possible, so I'm sure you're going to enlighten us as to what's happening with your innovation. So Frank, I believe you are first.
Yes, thank you, Marcus, for your nice intro of our company. And I would say that for us it was a kind of natural flow process that we shift from the Inkjet 2D business to the Inkjet 3D business. And I think the best way to illustrate that is that we focus a little bit on our real core competences we have in-house. And as this showed on the next slide, is that we, let's say, our basic core competences is that we can translate dedicated end-user requirements into sustainable chemical formulations. But also very specific on our approach is that always we link the chemistry to the technology. So we are always design new formulations in a system integrated approach. And when we try to implement these core competencies on the market, you can summarize it in 2 core activities. The first one is the innovative contract research, and the second one is development of innovative materials from the design phase to the industrial prototype, specifically in niche markets. And so when we have the kind of ChemStream at a glance, you see here that we are founded in April 2010, so we celebrate our 10 years anniversary already. For the moment, we have a staff of 14 FTEs, mainly PhDs. And as you can see on the slide, from the helicopter point of view, we are, let's say, situated more or less in the green fields of Flanders, in the south of Antwerp. And we have there facilities of about a little bit more than 500 square meters. As you can show at a glance, we have dedicated labs for formulating, for the chemical synthesis, and also, as I told you already before, that we can make also our own prototype production. And at the right corner, you can see here the production facilities where we make batches of inkjet inks of, let's say, about 25 liters per batch. Okay, now, inkjet at ChemStream, it's more or less in line with our core competences. When we focus a little bit more on the inkjet business at ChemStream, we say that we are mostly interested in inkjet inks with high added value, and mostly it's always low volume at that moment also. We focus always on inkjet with a high functionality, so we are not, let's say, interested in that much in the CMYK business. We always focus on the most difficult part, the high resolution applications. We try to make multi-material design of the materials. Why? Because it's very linked to our know-how related to the print strategies and also related to the process optimization. So when you combine all those focus points, the shift from the 2D to the 3D is in principle very natural. And I illustrated also with 3 market segments that I illustrated here in this slide, mainly the functional 3D printing materials, and the second one is the additive manufacturing. Specifically for the functional 3D printing materials, we can see that for our company, we can have a kind of shift from the pure ink business towards the material business, because we can link our ink formulation also to print strategies and process optimization, so that we can also, let's say, make the material design in real end-user objects. And this gives us also the opportunity that we can shift towards a high level in the value chain, from the ink towards the object. And I think it's very obvious that the high-end materials that we are deliver has to be supported by a well-known R&D research. And the second point is the second topic here is the additive manufacturing. There you can see that I say, for instance, in the automotive industry, that everybody is looking for a variety of mechanical properties. And you can go from the ABS-like towards the elastic or the rubber-like materials and tough materials. And it is very important there that we see and we have the perception in the market that the Inkjet additive manufacturing is very slow. It's a low throughput business, but we can see already that there's a shift from the low throughput systems to the high throughput systems. And I think it's worthwhile that we jump also in that type of business. And probably I can show you already with an example that the company DP Polar was introduced already in the Fornex last year. It is their process based on the high-speed rotative principle. You can see here that it is a kind of disc which is rotating below a dedicated number of printheads, where you can build up your material. And illustrated here in this promo film is that you can see that they illustrate here a multi-material build-up with a white and a magenta. But in principle, you can add there a lot of functionality in that build-up, in the build-up of the object. It is a very high throughput system. They consume about 10 liters per hour, and it takes almost, let's say, less than a minute to build up a cube of 5 by 5 by 5 centimeters. Okay, so I think now Marin is taking it over to illustrate the topics I illustrated in a generic way.
Hi.
Okay, sorry, operator, there are questions, please.
Over to you, Marin.
Yes. What we wanted to present are, let's say, a few specific 3D printed applications, so where Inkjet is used to 3D print the final object, and where you actually use the benefits of Inkjet 3D printing. You have, as Frank was saying, the high resolution, the high throughput for some industrial applications, but also the multi-material printing, that you can print different types of materials, different mechanical properties, different optical properties at the same time. And so you can have interwoven objects, or objects where you have different functionalities which are interwoven. And then it's not only that you have the advantage that the manufacturing is digital, which can be then personalized or customized, but the advantage is also that you can create objects which just could not be produced in any other way. And these are the kind of markets where ChemStream is involved in. And we have, let's say, two main applications as we could show here. A lot is related to optical objects like lenses, and then the other is, for example, for the creation of microreactors, microfluidic channels. So really objects which are not possible to be printed in any other classic or advanced manufacturing method. One example that ChemStream has been working on for many years is the inkjet printing of ophthalmic lenses, but also of optical elements in general. I have here a slide. I hope you can see it here. So it's a 3D printed lens, which comes as this out of the printer. So that's a big advantage. So inkjet, you start from a liquid drop, and then you build up your layers layer by layer by always printing and curing it when it's a UV curable. But of course, you can play with the flow of the drop before it's cured. And by this, you can have optically smooth surfaces, which is not possible by other 3D printing techniques, where you have really kind of stairs approach, step by step. You can be very precise, but never optically smooth. And so you always need to polish the objects or the materials afterwards. And these are the most expensive or the most time-consuming steps, is post-processing. And that's a big advantage. And we believe that inkjet for optical applications, even micro lenses and other kind of advanced optics, is a kind of unique technology. And certainly once you combine material science, what we do here, where you have an ink with a high refractive index, an ink with a low refractive index, when you start printing them together, and then a 3D pixel, so voxel-wise, you build up your material with these different materials. You can have non-linear lenses or gradient index lenses, and then objects which just cannot be manufactured differently. And then if you combine it with the high productivity of new printers which are coming on the market, we see it as actually a way to producing. So really it's a 3D production by inkjet printing. And this is, I think, a new field. And as material scientists, it's very exciting to work on these new products.
Interesting. Is with the technology, then you mentioned there are a couple of things that I thought were interesting. One, that inkjet enables things that other 3D printing processes can't match. So what are the other printing? There's stereolithography, is that right? Laser sintering, and they obviously have a special place, and inkjet has its own special place. And that's to do with the chemistry, is it? So you mentioned the smooth surfaces of the lenses that might require polishing. Is there any other sort of unique parts of inkjet 3D that can't be done in other processes?
It's so you're right that it's very unique. I think it's not only related to the inks, which we also traditionally develop here, but it's also related to the process. And the research or the development of these new manufacturing techniques, you really have this unique combination. And it's because of this combination of inks with different properties and then combined in the right process on how to print them, which allows or enables these new applications. Maybe to make it clear for everybody, I have a very simple slide about what we exactly mean with 3D inkjet printing. It's maybe very obvious, but then I think there is less, or there can be less misunderstanding, and then we can maybe compare it to the other 3D printing applications. So what we do is basically you print as in a 2D inkjet mode. So digitally, in this case, you have just one print head with one material, and then you lay down a first layer with the geometry that you want, and then you go to a UV curing station, and it comes back. So that's 2D. The thing is that you now have also the possibility to go down one layer, and then you add a second layer with another shape or the same shape, and you cure again. And so by repeating this over and over, you end up with your 3D object. This is, for example, one of the ways of how these lenses are printed, where you also play with the flow of the inks. And there's actually a lot of, besides material know-how, a lot of process know-how in order to be able to have these smooth surfaces. Of course, when you want to have more advanced geometries, also comparable with some other 3D printing techniques, you need a support ink. So it's a temporary ink that you print, and you print it together at the same time as the object. And it's also, in this case, a UV curable ink. And then you can do something which could not be done in the graphic above, is that you can print on the drawing a black part on top of air. So the support ink is there to support it, and then you cure again. And so you can see that by combination of a support and an object ink, you can basically make any shape that you like. A lot of material development have been at Chemstream to make a fast dissolving, water soluble support ink. So it's a UV curable ink that you print together with the object, and afterwards you just place the object in water, and then the support ink dissolves, and then you have the object. I can maybe directly jump to a specific application that we are for the moment developing, is the creation of microreactors. So it's microfluidic channels. I hope that you can see it on the camera, which in this case are designed for in the biomedical field, where you need cells to flow through these channels, and then it's actually incorporated in a bioreactor. So it's these microfluidic channels is a small part of a bigger thing. And there, the high resolution and with the supporting is important. And I come now to the advantages of these inkjets, so high resolution, but also the multi-materials. So you can print objects which are hydrophilic, hydrophobic, for example. Here also the cytotoxicity or biocompatibility is important. You can even in the future go to inks where you have specific adhesion to certain proteins, to certain cells and things like that. And so you can build up in the beginning maybe only microfluidic channels, but afterwards also functionality there in one single print job. So the idea is, when I come back to the drawing I just showed you, there was one object and one support material, but you can imagine to have one support and then 5 different objects where you have a hard, a soft material, hydrophilic, hydrophobic, and every functionality actually that you want. And that's one of the big advantages of this inkjet, is that when you compare it to, let's say, the organic 3D printing materials, I'm not speaking about laser sintering of metals and ceramics, which is, let's say, quite different from things that we do here. So you have to look at filament printing or stereolithography to be able to print many materials at the same time with that high resolution is very unique. And then you have some, let's say, extra benefits as optical smooth, so you can make transparent objects, which is not unimportant when you think of biomicroreactors, because they want to measure these cells through optical ways. So it's a demand of the field. Can we also look at the flow of the cells when they are in these microchannels? So, and then with these, because in the beginning there was a lot of, let's say, criticism about, yeah, but inkjet is always slow, so maybe it's interesting to do some research. But afterwards we have to produce it in another way. And then these new kind of printers where the output is that high, there is now also really the trust that 3D printing will also be able to really manufacturing the parts, high volumes of these parts for these applications. So it's not only a prototyping, it's really working on designing the manufacturing of these parts for the future.
Yeah, and that's interesting. So you mentioned obviously 3D printing, perhaps up to now, has been one of its perhaps supposed weaknesses is its scale, its speed to create things. With your technology, what you're saying there is it will be used, because initially I was thinking this is very specialist, so it will only be small numbers to do certain special things. But what you're saying is actually there's a potential for large volume.
Yeah, for sure. So I think that in the beginning we worked a lot on developing these very advanced materials where small series are possible. And that's also something that we are doing here, because there's so much process know-how that you actually shift from not only making the ink, but also really printing these parts internally with the quality for some. The second part is additive manufacturing, and we speak about industrial applications. There, it's really tuning these materials for being able to print really mass production of certain mechanical parts. So it really depends on the market, depends on the volume, depends on the complexity. But there is less limitations towards high numbers of parts. And when you look at, because you have to look at, when you look at productivity, it's not only about, as Frank was saying, like a cube like this, you can print out of the printer that you saw there, like one every, I think it's 50 seconds more or less when you look at the specifications. But it's the entire process. You don't have powders that you have to remove. So Inkjet in that sense very clean. You only add drops where you need them. And let's say that's a real benefit that we see this shift indeed of, let's say, more explorative material research towards, we are building materials which actually afterwards can also be produced in enough numbers at enough speed at a low cost for that application. Yes.
Yeah, and that's often I guess another stumbling block to mass adoption is if something's perceived to be far more expensive than the traditional method, and people tend to just kind of look at the small element and say, actually, well, that output compared to that output costs differently. But actually, your point is, which is a classical digital one, isn't it, is that actually you need to factor in the whole process, what it does.
Exactly.
And what is different to the actual, and the value is therefore discovered and managed properly, as opposed to just kind of discarding it as an option. Do you get the impression that 3D printing now is just far better understood by people that you're selling to, or is there still a misconception or misinformation about it?
I think that what you said in the beginning is very correct, that for the broad public, it gained a lot of hype through these prototypes, and it was very new shapes, and let's say this hype is over, and that you sometimes encounter the, let's say the will it be able to produce it in enough, at a low cost, enough volume, so these things are there. And you really see that it's kind of rethinking about new possibilities. And for us, it's a kind of really playground opening in entire possibilities. So it's not only about, sometimes you really have to forget even that it's digital. It just, you can produce, you make that object which you cannot make in any other way. And then you create new possibilities, new applications. And since these production modes are not known or not widely known up to now, or these possibilities, it's a lot by discussing with partners which are very advanced in certain technologies that we then cooperate with to develop these materials for a specific application. That's always our approach. It's not like let's make some part which looks nice. It's always, okay, for that application you need that. And this inkjet 3D printing, often in very fields which have nothing to do with inkjet or are very far away from each other, where you see that these printed materials can have the benefit. I have a small sample. It's something really just for, let's say, to be shown on fairs. It's you can make objects with embedded functionality. So it means that you can have nanoparticles incorporated with whatever property that you want. It can be hardness, it can be a special refractive index. We have made here a small block, so it's just printed. Then there is actually a fluorescent end in it. So it has no value except of showing the possibility that you can incorporate that. But then when you show this kind of objects at the fairs and people from very different fields, see them thinking, and then they come up with, oh, well, actually there are some maybe new possibilities. And there I think that's where we come in, where we go into detail and then develop project-based really for that specific applications, not only the ink, but the entire process to print that specific object.
So if somebody was approaching you then at this stage, because you have reached this exciting point with the technology that it can do these things, and is possibly at a very early stage still, perhaps. So how do you tend to work then? Would somebody come to you from a different industry, perhaps, that you hadn't anticipated, and said, we've got a great idea for using this, but we kind of need you to work with us in partnership? So you work on projects, do you? How does that work? If somebody wants to work with you, how would you go about that?
Yeah, there are, let's say, different types of general types of companies that we cooperate. It can be that, let's say, more chemical companies where they are creating building blocks. They see also these trends, and we have a lot of this process know-how. We actually look about kind of for them to create a platform, and certainly towards industrial application where you have mass production and trying to get all the type of material properties that you need. For example, that's a specific example of project that you have been working on, to have hard materials, soft materials, and all this in an inkjet printed with the good quality. Then we have also other types of collaborations where there are people from, let's say, working in specific fields. The microreactor that I showed you is in collaboration with a biotech company, where all the know-how about, well, okay, cytotoxicity, how the cells behave and things like that, and also from the application, it's like, okay, that's really coming from the partner, and then we translate these demands into, okay, what do we need to develop and the inks, and then you end up in a kind of win-win constructive collaboration where, and there's also a learning curve, let's say, in these projects where we at the end come for the entire application to the final object. So I think it's quite diverse, but we see that for the functional 3D printed objects, as Frank was showing in the beginning, so it's really for dedicated application, you usually make the difference when you have, let's say, our know-how in combination with a very strong application know-how. And then collaborating for many years together to come to that product, then you can come to the field with something, a unique product. And I think that's a powerful way of collaborating, and we try always to do that for, let's say, applications where this manufacturing method has a real benefit over the other 3D printing methods which are available for let's say, other types of markets.
And just thank you. And just sort of summing up, I suppose. Obviously, we've gone through a difficult period in the last few months with the pandemic and everything else. Has that changed demand for you at all, Frank? Obviously, it's affected everybody. Has this changed any sense in terms of the kind of inquiries you're getting, or the kind of interest in the products? Are you getting? Is there any change there? Is it an increase or a decrease?
Yeah, specifically for the testing of the vaccine, and also the medical environment, of course, what is called the lab on a chip application, as Maria also introduced it already a little bit, where you make a kind of complete bioreactor with different types of microreactors to see how cells and how the medicines are influence the physiology and the metabolism of dedicated stem cells. There, of course, is a huge interest for the moment. And of course, here in Flanders, there are dedicated spin-offs of the universities, of different universities, where they are focused on the microfluidics and the bioreactors. And there, of course, we are involved in dedicated programs, for sure. Yeah, there is indeed let us say, more interest in that field. But also, I think, specifically in the automotive industry, where you come to more personalized designs or something like that, there is also a very huge interest, and that's had nothing to do with with COVID, but it's more general in interest. Of course, the focus has to be let's say, lay on the real mechanical properties. And I think, Marin, you didn't show that, but we have here a lot of, let's say, types of standardized or ISO normal, normalized workflows, where you can show the difference in mechanical properties we can reach with the 3D printing already.
Yeah, indeed, and also, I mean, come to the COVID question, is let's say these kind of collaborations are long-term collaborations, and then usually, let's say that these companies continue to invest for the research and the development of the products afterwards. So let's say that we haven't directly felt so strongly this impact, and to come to that, indeed, so we have. It's a project that was very active, let's say, during the COVID period, is actually to make materials which are very hard or very soft. And then we 3D print these kind of dog bones on our printers here, and then we test them. And then you can actually make the entire set of properties which are needed.
Okay, very good, very interesting. So for people who want to find out more information, they can look at your website, chemstream.be. You both have a profile on the Futureprint Summit site. So if people want to connect with you, send you an email, have a discussion with you afterwards, I assume you'll be taking part in some of our networking throughout the week. So opportunity there too. So I want to thank you both for delivering a very interesting, different and unique 3D with Inkjet. I think really interesting area, clearly at an exciting point for the future. And thanks so much for being part of the event, for being a content partner. And I wish you every success with this new idea and new technology. Thanks, gentlemen.